Hello Flat Earth researchers, debaters and debunkers. Here is a ball, and I'm going to prove to you that horizons that we can see in the distance are not the same as being on a ball. Okay, horizons are not curvature. Here we can distinctly see the results of curvature on this ball. When we rise up, it stays fixed in place, okay? The horizon quickly drops away because this is a physical curve, and it will stay where it is as we rise above it, okay? That is what happens when you observe a ball. So now, what we do is I'm just putting this on a tripod. Okay, tripod there. Okay, camera's on the tripod now. I'm not sure if it's 100% level. I don't have a leveling thing with it. So I'm going to stick this in the ground. Doesn't matter where and doesn't matter how deep it goes. It's just to give you a visual reference of what happens to the horizon. It doesn't happen to the ball. We keep the ball there. You can see that it just is its thing. So you can take note of where the horizon appears to be right now in the thing, in the camera. And as we rise up, dun, 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 look at that, the horizon remains at our eye level. Okay, come back down again. We can see that as we rise up and down, we go up and down in height. The horizon comes with us. That means that it is a flat surface as far as we can see. Okay, compared to this ball down here, which is a fixed curve. So this horizon we see in front of us is not a fixed curve. Do you want to see it again? You can do this every time. Okay. The fact that you can do that demonstrates to us that it's flat. You make all the excuses you want, all the explanations you like, but that is flat and that is round. Not the same. We live on a flat earth, and horizons are not curvature. Because look at what the problems you have if you try to measure distances based on horizons. How can you when the horizon is constantly changing? Yeah, you can't measure, you can't have a side-on view and measure the horizon, can you? Can't do that if it's constantly changing with your height and coming with you. It's ridiculous. Okay, Earth is flat, it's not round. Get over it, wake up.
Okay, here's another example. You can see here that this vinegar bottle has a measurable height. Again, this is buried in the sand. It doesn't matter, but let's just say it's 9 inches, okay? That is the height that we can see. Now, as the observer, if that ruler wasn't there, how do we know that's 9 inches? Yeah? I mean, that's, we get closer and farther away, okay? Angular size changes. And here we have one here. Look at this, another bottle, okay? How do you know now that this is 9 inches? Because if we take a line from here to here, it looks more like, I'm not sure from here, but 12, 13, okay? And the higher we go, I mean, so the lower we go, the greater that difference is going to be. Yeah? Okay? So unless you can measure physically the distance, what we see in the camera lens or the eyes makes no difference. Or you can't measure, that's different. Yeah, you can't actually physically measure it. So physical measurement and an observation are different, and we can see that it will vary. All right, but the only thing one thing we can do is get a very direct line of sight. And would you look at that? The horizon is there as well. Okay, we can come down, and the horizon comes down with us. We can come up, and the horizon comes up with us. Yeah. Okay, very simple stuff, and only when we are directly in line with it can we see the real height of the other one. Of course, I could say that I'm in line with it by tilting it like that and bring the other one down. Oh, look at that, the other one's lower now in the background, and I can say, oh, but I'm at the same height because it's at my eye level. Yeah, So, you know, you can tell when you're being deceived. All right? It's very simple to work out. Yeah, to see the difference here. So, see, you can't use this measurement anymore. Has nothing to do with this measurement now, or this apparent measurement now. This is going to be completely different to what this physically is in the background. Yeah, okay. We can see again that the horizon remains at eye level. Okay, so again, you know, the background it remains at eye level, the horizon. Very simple stuff, okay? Very easy to deceive people who want to be deceived, who want to hold on to a belief. Yeah? If you want to talk about making comparisons and measuring curvature on the Earth, well, first of all, mountains are a ridiculous thing to do, but you have to be at the top. At the top, and you have to demonstrate that you're at the top, and then everything will line up. But when you've got pylons going off into the distance, this is what happens when you're below the pylons. It's very simple. Yeah, but of course, this is why we demand a side-on view, because then, if you have it, you'll either see that it is flat and horizontal, or if one is taller than the other, that's when you will see the curve. Okay? So, there you go. It's just a very simple way of demonstrating what can actually happen. And again, we can see that the horizon, regardless of these objects here, the horizon is always at eye level. Okay? There you go. Should be enough. Thank you very much.